Alright students, we're going to continue with our notes for theoretical and experimental probability, and we're going to look at this table right here which illustrates both. Okay? Now on the left hand side is theoretical probability. That's just in theory what is the likelihood of something occurring. Now if you're looking at a dice, then there are only 6 sides and there is just a different number, 1 through 6, on each side. So the probability of rolling a 1 is only 1 out of 6. And it goes the same for all of these. The probability of rolling a 2 is 1 out of 6 because there's 6 sides. The probability of a 3 is 1 out of 6. 4 is 1 out of 6. Probability of 5 is 1 out of 6. And probability of 6 is still only 1 chance in 6. Now that differs greatly from experimental probability. Now, experimental results are illustrated here. And what we're going to do is let's find out what occurred when a dice was rolled, or a cube as they call it, 50 times, okay? So if I were to look at this, and somebody's done the experiment for us already, and let's determine how many times they rolled each one out of 50. Look at this, this is quite unusual. They rolled 1 10 times out of 50. So 10 out of 50, that simplifies to 1/5. Let's look at 2, the probability of 2. They rolled it 4 times out of 50 rolls. 4 out of 50, but that simplifies to 2 over 25. Okay. Probability of 3, 8. So they rolled it 8 out of 50. And that simplifies to 4/25. Probability of 4 is right here. Look at that, 11 times. Now 11/50, guys, does not simplify. The same with 5. 11 times out of 50. 11/50. And 6, let's look there, is 6 times out of 50. So you notice the experiment doesn't always match the theory. And let's simplify this to 3 over 25. Okay, now let's make a prediction. It says if you rolled a die 90 times, how many of each would you expect to get? Alright, well that's interesting because in this particular case, it's making a prediction. Well, predictions would be based on your theory, not what actually occurs, okay? Well, I would build a proportion to find out. Well, I know that if I roll a 1 and 6 times, I get a 1, or 2, or 4. Make a prediction, roll a die 90 times, how many of each would you expect to get? So we're going to do this first, theory. 1/6 equals x over 90, right? So we multiply the diagonals, divide the other side. So that means 6x equals 90, divide both sides by 6. And so my prediction here would be an outcome. In this case, we do not write a fraction, okay? And so that would be 15. So I'm likely going to get it 15 times. Now, because we know all the probabilities are the same for each side of the cube, rolling a 4 would be the same. It would be the exact same proportion. And we've already worked this out, and we know that x equals the likelihood of 15 outcomes being a 4. Now let's look at the next part. In this case, if I do the proportions using this information for 90 times, I'm going to get a different answer based on the experiment itself. So let's look. Rolling a 2. Up here the probability of rolling 2 was 2 over 25. Well, if I do that 90 times, 2 over 25 equals x over 90. I'm going to multiply my diagonals and divide the other side. I'm going to end up with a decimal answer. So I'm not going to get an exact number for outcomes. So that is 25x equals 180. And divide both sides by 25. Would you like to calculate this also as I do? So 180 divide 25 is how we find our answer. And that is 180 divide 25, 7.2. So the likelihood is I would roll it 7.2 times. Or I'd round it and say about 7 times. Okay, let's let's try the 4. Now in this case, the 4, the probability is 11 out of 50. So 11 over 50 equals x over 90. So you multiply diagonals again, divide the other side. 50 times x is 50x, right? And then 90 times 11 is 990, I believe. We divide both sides by 50. Going to get a decimal answer again, guys. X equals, and 990 divide 50. 19.8 is what I get. And I'd probably round up and say it'd be about 20 times I would roll a 4.